Hello students, sorry I'm not there today, but today we're going to be starting our first day of U substitution. We'll be spending a couple days on this topic. I'll be there on block day to kind of clean it all up. But basically the idea is this. We're trying to find, this should be to the fifth power by the way. We're trying to find out what this integral would be. And right now, the only way we know to do this is to keep on expanding it out to be something really a lot to do. And that's just not doable. That's way too much work. There is a much better way of doing this. Again, this is to the fifth power. What we're going to do is do U substitution, like in sports. You substitute someone in for another person. In this case, I'm going to substitute the letter U to equal x plus 2. So in my integral, everywhere I see an x plus 2, I'm going to change it to the letter U. Now you notice there's also a dx here. So what we do on this is we take the derivative of both sides, okay? And now we can replace. This integral becomes U to the fifth power, and the dx gets replaced with a du. Now, that integral is much easier to do. In today's assignment, this is just as far as you'll go, but if you were to continue, you know what, we're just going to stop there. This is as far as we're going to go. This integral is pretty easy to do, right? Add 1 to the power, divide by the new power. We're going to be working on that tomorrow. But today I just want to work on getting things to look like this. So let's take another one here. Again, we're going to go ahead and let U equal the part that's all messed up, this inside portion. And then to get to dx, we're going to take the derivative of both sides. Now you'll notice right now we've got a 4dx here instead of just a dx. So what I'm going to do is I'm going to divide both sides by 4. And so now I got a straight thing to substitute in for the u and a straight thing to substitute in for the dx. So our integral becomes the square root of u, right? Because that's what 4x minus 1 is. And then the dx gets replaced with du over 4. And we can write this a little bit nicer by pulling out the 1/4. Getting an integral that's much easier to deal with. So again, we've got to remember that we're going to be substituting out for the dx and also plugging u in for some terms to make it a little bit easier to do. So here's another one for us to do. I want you to think, okay, what would u have to equal? Well, hopefully you're thinking 7x plus 5. Now we'll take the derivative of both sides and get du equals 7 dx. And then I got to solve for dx. So dx equals du over 7. So there's my substitution step for the dx, and here's my substitution step for the u. And so our integral becomes the cosine of, well, I believe all of this stuff is a u, right? This inner portion. And then the dx gets replaced with du over 7. So if we rewrite this, we can pull the 1/7 out, and we have this. And again, this is what you're going to be doing today. We're just kind of starting off with these. Now, these do get a little more interesting. Like these ones we just did, we're not too bad, right? Just one term. But now we've got something like this where we've got kind of two functions, don't we? We've kind of got this and this. Well, the idea on picking what u should equal, a good rule of thumb is whatever you let u equal, when you go to take its derivative, you should see some form of that derivative in the integral you see. So for example, if I said u equals 2x and I take the derivative of both sides, you know, I don't see how I can take care of this x squared business that way. What I should do is let u equal 1 plus x squared. That way when I take the derivative, you know, I can kind of see that in there. Now, there is a way I could go from here, but I'm going to kind of try to stay consistent with today. So I'm going to get dx by itself, and that becomes du over 2x. Now, I do my substitution steps here. And again, all of this gets replaced with the letter u. Now we still happen to have a 2x here, right? Still have a 2x there. But the dx is going to get replaced with du over 2x, right? From right here. And so if we do this correctly, those will cancel out. And we will be left with just the integral now of the square root of u du. Much easier to do. Now I know I could have substituted a little bit differently there, but I'm going to keep with this method because I think we're going to see some things in a couple problems that make sense as to why we're doing it this way. But all we want to do is try to rewrite this complicated integral into something that is much easier to deal with. Okay, take a look at this one. Think of what would u equal? Well, I think u would equal x cubed because the derivative of u would be 3x squared dx, and I happen to see an x squared in the problem. So solve that for dx. Here's my two substitution steps. We have x squared sine of not x cubed anymore, but of the letter u, because that's what x cubed is equal to. And then this dx gets replaced with du over 3x squared. Well, we can see the x squareds cancel, and we are left with the integral. Now this 3 I think we're going to pull out, 1/3 sine of u du. And this integral, again, will be much easier to figure out. Okay, we have like 3 more to go through, and hopefully this is getting a little bit more interesting here. Here, we're going to let u equal sine of x. And that means du is equal to cosine of x dx. Solve for dx. And I'm letting u equal sine because of this fourth power, right? It's sine to the fourth power. So let's make that be just u to the fourth power, so it's easier to deal with. So we have u to the fourth power, and then we still have that cosine of x, but now the dx gets replaced with du over cosine of x. Well, cosine of x is canceled, and we're left with the integral of u to the fourth du. Again, much easier integral to do. Okay, last two. What do you think u would equal on this one? Tangent or secant squared? Hoping you're thinking tangent, because if we take the derivative we will get secant squared. And again, solve for dx. Here's our two substitution steps. And tangent is getting replaced with the letter u. And dx is getting replaced with du over secant squared of x. So those cancel. And we are left with the integral of u du, which is a much easier integral to do. All right, last one here. We're going to let u equal x cubed plus 1, and then take the derivative of both sides. And then solve for dx. Here's our two substitution steps. So we have 3x squared and integral, but then that square root portion becomes the letter u, and then the dx becomes du over 3x squared, which those cancel. And we are left with the integral of the square root of u du. And so today for the assignment, it's on Google Classroom. That's where you found this video at. You are going to do a circuit. I believe there's 14 of them. And all it involves is taking an integral like these on the left and rewriting it like an integral on the right. Now, there's one small thing that we need to talk about here. On that assignment, what's going to happen is, like this problem that we just did, what if it was really this, the integral from 1 to 5 of x plus 2 to the 5th power dx? Now, we would still do all the same stuff here, right? But we've got these limits here on the integral, and those limits are in terms of the variable x, and we need to change them into the variable u. So what we do is we just plug them into our substitution step. 5 plus 2 is 7, so the upper limit now becomes a 7. Plug the 1 in. 1 plus 2 is 3. That lower limit becomes a 3. And we would have this. That's the one extra piece you'll have to do on the assignment. I did post the solutions also, so you can check them out. Tomorrow, we're going to go on in a little bit more depth on this. But today is just about rewriting. So hope you do well. And again, send me a message if you need some help.